Alright, boom. So quick question. The values in the table below represent a function. Identify the rule and express it in the form f of x is equal to ax plus b. Just to remind you all what a function is. A function takes an input, x. So you're going to take a number. You're going to do something with that number. And it's going to give you the output, commonly known as f of x or y. Right? So, and they're telling us that the relationship needs to be in this form, which is a linear relationship. But let me not confuse you guys with any fancy words. To do this, I'm going to pick an ordered pair, right? Let's just say I pick 2 and 10. So in other words, for my function, when I have an x value of 2 and I plug in 2, you know what I'm supposed to get? Well, according to the function, I'm supposed to get 10. So I'm going to write f of x here. And to get my answer, I need to multiply x by some number. And then I need to add another number to this result. And when I put 2 into the function, right? When I put 2 into the function and I add a number to it, what am I supposed to get? Well, according to the relationship here, I'm supposed to get 10. So 10 is my answer. I want to get 10, right? So I want you to think to yourself now, what I could multiply by 2 and then add to get 10? Well, I'm seeing here that we could potentially multiply 2 by 3. And, maybe I could add 4 to that. Let's see if that would work. 3 by 2 is 6. 6 plus 4 is 10, right? So that is correct. Now, we came up with our function here. You're not just going to write down the answer one time. You need to see if that relationship holds for the rest of them. So now, I'm going to write my test function. Alright, so we came up with what? We said that, if you multiply 2 by 3 and you add 4 to it, you'll get the answer. So in this test function, the number you're multiplying x by was 3, and the number you was adding to that result was 4. So my test function is 3 by x plus 4. Now, if this is correct, it should hold for all the other sets of ordered pairs. So let's pick a random one. What about 1, 7? So when x is 1, what am I supposed to get? Well, I'm supposed to get 7. Let's see if that's true. So I'm going to put 1 into that. And that's going to be 3 by 1. So anywhere that you see x, you have to replace it with 1. Because that's what you're putting into the function. What is 3 by 1? 3 by 1 is 3. 3 plus 4 is, well, 7. Nice. So does it work for more than 1? Yes, it does. Ideally, you should do it for the rest just to make sure the pattern holds. But it does work. And so your answer is f of x is equal to 3x plus 4. And in case you have trust issues, maybe we could do it for one more. So what about minus 1, 1? So when x is minus 1, what am I supposed to get as my output? Well, according to the relationship, I'm supposed to get 1. Let's see. So 3 by minus 1 plus 4. You're going to end up with minus 3 plus 4. So essentially, you're taking away 3 from 4. If you do that, you'll remain with 1. So do we get the correct output? Yes, we do. So that was one way you could do it. So my answer is f of x is equal to 3x plus 4. Method 2 now. You can see that this is a linear relationship, right? Which is in the form y is equal to mx plus c. So f of x is the same thing as y. Remember, when you take an x value and you put it into a function, you get an output. We call that output y. So f of x is the same thing as y, and I want you to make notice of this thing over here. So the x value is increasing by a multiple, right? In this case is a, in this case is m. Different letters to represent the exact same thing. So I want you to understand that a is just a gradient, and the b value is just a constant c, which we know to be the y-intercept, right? Great. So to answer my question now, I could find the gradient because a represents the gradient, and I could look to see if we have the y-intercept anywhere. So we have a set of points, right? Let me show you what I mean. So remember I was talking about ordered pairs. So this is the set of x values, these are the inputs, and these are the set of y values, these are the outputs. So a coordinate is made up of an x and a y value. So this first coordinate would be minus 1, 1. Because when x is minus 1, y is 1. Nice. Over here, it'll be 0, 4. Because when x is 0, y is 4. Over here is going to be 1, 7. And over here is going to be 2, 10. Now for me to find the gradient, remember gradient is just the change in y over the change in x. So that's y2 minus y1 all over x2 minus x1. So for me to find the gradient, I could select any 2 points over here, right? Because these points will form a line if I graph it out. So to do this, I'm going to pick 2 easy points. I could pick 0, 4 and 2, 10. Let's just call this x1, y1. The order in which you pick this does not matter. Eh? You could have called this x2, y2, and you could have called this x1, y1. It does not matter. You'll get the same answer. So my gradient is going to be 10 minus y1, which is 4, all over x2 minus x1. x2 is 2, and x1 is 0. What is 10 minus 4? That's 6. 2 minus 0 is 2. So we get the gradient to be 3. Aha. So just like that, we were able to find for A. So we figured out the first part of our puzzle. So we know that A is equal to 3. Nice. Now we need to figure out the y-intercept, which corresponds to B. Now, what is the x value at the y-intercept? That is what I'm going to ask you guys. So at the y-intercept, let me show you something, right? I just drew a random line here. Now, the y-intercept is where the graph is cutting the y-axis. For those of you guys that don't know, this is the y-axis and this is the x-axis. If you look at the y-intercept, it is cutting the what? It is cutting the y-axis. So if it is cutting the y-axis, then it is on the y-axis itself. So the x value would be equal to 0. Because if you are on the y-axis, you could only move up or down. So your horizontal movement is 0. Understand what I'm saying, right? If the point was over here now, well, to reach that point, you would have to travel a horizontal distance and then a vertical distance. But if you are on the y-axis itself, you are just moving up or down. So what is your horizontal movement? Your horizontal movement is 0. Why? Because if this is the point, right, I think all of us could see that it is on the y-axis. It doesn't have anything to do with the x-axis, and it's not being shifted left or right. It's staying there. So at the y-intercept, we know that the x value is equal to 0. So what we could do now is we could now come to our table and let's observe. Do we know what x is equal? Do we know what y value you get when x is 0? The answer is yes. When x is 0, you are getting 4. So that is the next part of the puzzle complete. So in other words, the y-intercept is 4. Because at the y-intercept, x is equal to 0. Lovely. And just like that, we figured out what A and B is. Nice. So my function would be equal to 3x plus 4. And that is the second method down. There's another method you could use. On to the third method now. I have a feeling not much of you guys will like this one, but it's really, really cool. When we look at the function, how much unknowns do we see? Well, if you ask me, I'm seeing A and B. You might probably be saying, well, sir, x is an unknown, right? Not in the sense I'm talking about, right? X is a variable, and you would, whatever x is, you just plug it in. So at any given time, x wouldn't be an unknown, right? If I told you x was equal to 1, then that would be replaced with 1. And as you can see, that leaves us with A and B. So 2 unknowns. Anytime you have 2 unknowns, I want you to think simultaneous equations. So if I want to solve this using the third method, I need to come up with a system of 2 linear equations. And to do this, we are going to take any of the x values there, any 2 of the x values, I'm going to plug it in to make 2 equations. So I'm going to pick say x is 0, and I'm going to pick say x is 2. No problem. So when x is 0, so I'm going to put that into the function. That's going to be A by 0 plus B. And we know that when you plug 0 into the function, what are you supposed to get? You're supposed to get 4. So I'm going to write 4 over here, and that is supposed to be equal to A by 0, which is 0, plus B. What is 0 plus B? Well, 0 plus B is B. Wow. So just like that, we were able to figure out for B. On to the second one now, which is when x is 2. So when x is 2, so I'm going to say f of 2, that's going to be A by 2 plus B. And when you put 2 into the function, what are you supposed to get? 10. So I'm going to replace f of 2 with 10, because you know that when you put 2 into the function, you are supposed to get 10. So that's going to be a by 2, which is 2a, right, plus b. Now, earlier, we solved for b. We actually know what b is, right? B is actually 4. So anywhere that I see b over here, I'm not going to leave it. I'm going to write 4. So 10 is going to be equal to 2a plus 4. Now, in this scenario, we just have to solve for a now. So we have to make a the subject of the formula. Notice where a is. A is actually on the right-hand side, so we could leave it there and move across all the other numbers to the other side. Now, some of you all might be like, sir, and I can minus 2 from both sides? And the answer is no. This 2 is here to signify that there are 2 a's on the right-hand side. So that 2 is actually part of the a term. So what you could do though, you could actually move across the plus 4. If I were to move across the plus 4, the signs would change, and that would be 10 minus 4 is equal to 2a. Another way students like to think about it is by subtracting 4 on both sides, because we want to get rid of 4. So you'd have to take away 4 on both sides. So you're going to end up with 10 minus 4. 10 minus 4 is 6. 6 is equal to 2a. If 2 times a is 6, then a would have to be 3. And the long way to do this would be to divide both sides by 2. That leaves us with a. So 6 over 2 is 3. So a is equal to 3. Bam! Just like that, we were able to figure out what a and b was. So again, I got the same answer. F of x is equal to a is 3, right? X, and b is 4. On to the alternative method, which is just like a little plot twist on number 3, right? Let's just say instead of picking 0, 4, you wanted to make your life a little hard, so you're gonna pick say minus 1, 1. So instead of plugging in x is 0, let's plug in x is minus 1. So that would be f of minus 1, and that would be equal to a by minus 1, because we know x is minus 1, right? Plus b. And when you plug minus 1 into f of x, what are you getting? You're supposed to get 1. So I could replace f of minus 1 with 1. So a by minus 1 is minus a, right? Plus b. You see what I'm talking about? You're ending up with an equation in terms of a and b. So let me show you what you gotta do next. Anytime you end up with two equations with two unknowns, again, think simultaneous equations, right? And once you have a system of two equations, for two unknowns, you can solve it very simply, either using elimination or substitution. Now, for the sake of this, I'm going to do elimination. It's the quickest thing. It's the quickest thing. So I could call this 1 and I could call this 2. I'm just going to rewrite it. So instead of me putting 1 on the left-hand side, I'm just going to write it on the right-hand side. So I could write minus a plus b is equal to 1. And then I'm going to write the second equation directly underneath that. So that would be 2a plus b is equal to 10. Now this is really simple in the sense that if I subtract these two from each other, the b and the b will cancel off. I hope you see what I'm talking about. If I ask you where is b minus b, that would be 0, right? Because the b would take away the b. Simple. So we have minus a minus 2a. So minus a minus 2a. Imagine you take an apple from your friend and then you take 2 more apples. Altogether, you would have taken how much? 3 apples. You're a real greedy boy. Way. Alright, minus 3a. And then again, b minus b is 0. Why do we need to do that? You need to do that because at any given point in time, you could only solve for one unknown. So be careful, right? That's why we took away. We took away such that the b term would be eliminated. That's why we call it elimination. And in doing that, now we just have the unknown a, which we could solve for rather simply. So we're going to get 1 minus 10 here. 1 minus 10 is minus 9. So our problem boils down to minus 3a is equal to minus 9. So if I want to find for a, I would need to get rid of that minus 3. And so since a is being multiplied by minus 3, I could divide by minus 3 on both sides. Nice. So a is going to be equal to minus 9 over minus 3. The negative and the negative would cancel off. Another way you could think about it is a negative divided by a negative is a plus, right? So my answer is going to be positive. Now 3 into 9 is 3. So a is going to be equal to 3. Lovely. So I just found for a is equal to 3. If you want to solve for b now, you need to pick either one of the two equations, it doesn't matter, and you're going to plug a into it, and you're going to make b the subject of the formula. So I'm going to pick equation 2 for this quickly. So if I pick equation 2 says 10 is equal to 2a plus b. Now, we know that a is 3, so that'll be 2 by 3 plus b. All I did was, I just substituted what a was. A was 3, right? So instead of writing a, I wrote 3. 2 by 3 is 6. So we end up with 10 is equal to 6 plus b. Now, I want to find for b, right? B is the only unknown here, so I could find for it. So for me to do that, I'm going to take this positive 6 and I'm going to move it across. If I move across positive 6, that's going to turn to negative 6. So 10 minus 6 is equal to b. So what is 10 minus 6? That's 4. So 4 is equal to b. So b is equal to 4. Again, we got the same answer as all the other methods, right? So I can summarize now. So f of x is equal to a is 3x, plus b is 4. So I hope that was really, really insightful. If you like content like this, where we go in real in-depth, subscribe to my YouTube channel and follow, because there's going to be a lot more content like this. Anyways, later guys, I go on there.